So this is adding integers, and just a few things. First of all, I'd like to say for adding integers, many of you have been taught by perhaps several different teachers on how to add integers, but I want to give you the concept behind it so that you can correctly do it, because I find a lot of mistakes here. So I'm going to take it back just a bit, then we'll go ahead. Adding integers. First of all, I want to go back to science, something that we learned about, which is positive and negatives. If I have a positive and I have a negative, in terms of proton, neutron, and the such, electrons, I should say. When I have a positive and a negative together, if a positive and negative are together, if I have one positive and one negative, it's equal to 0. It's worth nothing. So basically, if I have $1 and I owe somebody $1, I really have no money. So let's understand. If I have 2 positives and 2 negatives, that's a 0 pair, so this is worth nothing. What I'm saying is, 1 positive, 1 negative is equal to what we call a 0 pair. It's worth nothing. So this is 1 0 pair. When I had 2 positive and 2 negatives, this was 2 0 pairs. So they were worth nothing. Right? So just understand that. Okay, here's the next thing. If I have 3 positives and 2 negatives, what does that equate to? Well, how many 0 pairs do I have? There's 1 0 pair there and a second there. They're gone. So what is this solution worth? It's worth a positive 1, because I have 1 positive left. Next thing, if I have 2 positive and 5 negatives, what do I have? Well, let's get rid of all the 0 pairs first. We always want to get rid of the 0 pairs. There's 1, 2 0 pairs. What's left? It's all in one charge, which is a 3 negatives, or negative 3. All right, so let's go ahead and begin our adding integers. Let's start with the first example. Please be sure to take your notes. If I have a positive 3 plus a positive 2, when we're adding integers, there's a few rules that we want to do. First of all, the first rule that we want to do, first rule is represent the first number. Represent the first number, and I'm using that as the pound sign. So, if I have a positive 3 plus a positive 2 to represent the first number, that means I have 1, 2, 3 positives. This plus sign here means to add. So it's telling me to add on what? It's telling me to add on 2 more positives. So I'm going to add on 2 more positives. 1, 2. My final answer should be in the same charge. Is my final answer in the same charge? The answer is yes. Count them up. I have 1, 2, 3, 4, 5 positive. So this answer is a positive 5. So, in my rule, first thing I want to represent the first number. And then the second thing that I want to do is add the second number. And then finally, or third, get my final answer in one charge. In one, or I should say, same charge. Alright, and we've done that here. Okay, we represent the first number. That was step 1, the plus 3, and then it says to add. Add, that was the second thing, to add on what? 2 positives. Final thing was to make sure our final answer are in the same charge, and it is. It's a positive 5. Let's try another one. Some of you are going, huh? What are you talking about? So here's example 2. Positive 3 plus a negative 2. First rule. First rule says represent the first number. So if I represent the first number with a positive 3 plus a negative 2, represent the first number, that means I'm going to have 1, 2, 3 positives. I've done step 1. I represented the first number. Second, add the second number. So here we are. Let's add the second number. It says add. That's what this plus means. Add the second number. Add what? 2 negatives. So I'm going to add on 1, 2 negatives. Okay? Here we are. Get the final answer in the same charge. Well, let's see what our final answer should be here. Final answer, we need to get rid of the 0 pairs. How many zero pairs are there? One, a positive and negative, which we did in the very first slide, is worth nothing. That's gone. And there's a second zero pair. That's gone. That means that our final answer should be in the same charge. And is it at this time? It is. So that means a positive 3 plus a negative 2 is equal to a positive 1. Moving on, let's try another one. Example 3 is a negative 6 plus a negative 2. What's the first rule? First rule says to represent the first number. So that means that we need to represent or to get 6 negatives. 1, 2, 3, 4, 5, 6 negatives. Rule number 2 says to add the second number in. So we're going to add plus 2 positives. 1, 2. And the third rule says to get everything in the same charge. Well, before I do that, I need to get rid of zero pairs because I got a mismatch of negative and positives. So there's 1 zero pair, 2 zero pairs, they're gone. Is my final answer in the same charge? The answer is yes. It's a negative 4. So that means that negative 6 plus a positive 2 equals a negative 4. Let's try another example here. Example number 4. Negative 5 plus a negative 2. First rule, represent the first number. There are 1, 2, 3, 4, 5 negatives. The second rule says to add the second number. We're going to add on 2 negatives. 1, 2. The third and final rule says make sure everything is in the same charge. In this case, everything's in the same charge, so there's no zero pairs to get rid of. So that means that we have a negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So negative 5 plus negative 2 is a negative 7. Our final answer is in the same charge. Well, what's the rule? First of all, let's understand this here. Well, I have another one here. Let's do this one here. Example 5. Represent the first number. 5 positives. 1, 2, 3, 4, 5. It says to add on 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. Third rule says to get in the same charge. Well, I've got some zero pairs to get rid of. Gone, 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 gone. There are 5 zero pairs that go out. I'm left with 3 negatives. So 5 positive 5, plus a negative 8 equals a negative 3. That's done and out of the way. Well, I'm thinking to myself, I'm not going to want to draw all these positive and negative charges. For example, if someone gives me a problem and they say 14,784 plus a negative 32,147, I'm not going to draw all these negative and positive. There's a shortcut, okay? And that shortcut simply says this. If I start at the top, when I'm adding the same charge, in an addition of integers, when I'm adding integers, it's an addition problem. When I'm adding integers and they have the same charge, positive and positive, they have the same charge, you just add them. 3 plus 2 is 5. And I know it's a positive sign, 5, because both of them were positive. Again, I'll say that. When I'm adding integers and they both have the same charge, in this case they have both the same charge of positive and positive. When I'm adding integers and they have the same charge, positive, positive, I'm just going to add the number. 3 plus 2 is 5. How do I know if this charge is 5 is positive or if it's a negative 5? Well, the 3 was positive and the 2 is positive, so it's going to be a positive 5. Let's look at example number 2. When I'm adding integers and they have opposite or different charges like they do here, a positive and negative. When I'm adding integers with different charges, it's really a subtraction problem. This is really 3 minus 2. 3 minus 2 is 1. The question is the one going to be positive or negative? You always mark this charge of the bigger number. 3 is a larger than a 2, so it's going to be a positive 1. 3 is larger than a 2, so you use the charge of the bigger number if you took the absolute value. 3 is bigger than 2, so it's a positive. There are more positives than there are negatives. Let's look at the next one. I'll erase this out of here. This problem here was a negative 6 plus a positive 2. We're adding integers. When we're adding integers and they have different charges, again, it means it's a subtraction problem. So this is really 6 minus 2. Well, 6 minus 2 is equal to 4. Change the color here. Is 4. The question is this 4 positive or negative? Well, 6, generally a 6 is larger than a 2. So I'll go directly to the 6, and I look at the charge of the 6, and I see it's negative. That automatically means that my 4 is going to be negative. Next, let's look at example number 4. Again, I'm adding integers. This time I'm adding integers with the same charge. When I'm adding integers with the same charge, negative and negative, I'm adding the same charge, you just add them. This is just 5 plus 2. 5 plus 2 is 7. How do I know if the 7 is positive or negative? Well, both of them are negative, so you just slap the negative back on there. That's what we did in example number 1. We were adding integers with the same charge. When we're adding with the same charge, we just go ahead and add the numbers. 3 and plus 2 is 5. How do I know if that 5 is positive or negative? Well, both of them were positive, so you just slap the positive on the 5. Let's look at the next example. Example 8. I'm adding integers, but I'm adding integers with different charges. These are different. There's a positive and negative. When I add integers and they have different charges, it's just a subtraction problem. You can just say 8 minus 5. It doesn't matter if the 5 is front. It doesn't matter. It's just 8 minus 5. 8 minus 5 is 3. And then I go, what's the charge on this 3? It always takes the charge of the bigger number. 8 is larger than the 5. I'm not worried about it's a negative 8 and a positive 5. 8 is larger than the 5. So this 3 is going to be negative because 8 is a bigger number than 5. So this will be a negative 3 for my final answer. This helps me avoid having to draw these positive and negative if I know the rules. Okay? So what's the rule? Simply here, when I'm adding, this is the rule. When you add integers, if the charges are the same, whereas in example number 1, go back to example 1. Okay? In example 1, I'm adding integers with the same charge. You just add them. 3 plus 2 is 5. This final answer gets the charge of what's the same of them. So when I'm adding integers and they have the same charge, we just add the numbers. The 3 and the 2 made 5. Okay? And it's going to be, the charge of the 5 is going to be the same as the charge of both the numbers. The 3 was positive and 2 was positive, so the 5 also was positive. If the charges are different, in an addition problem, if the charges are different, then we just subtract and use the charge of the bigger number. What do I mean? Just really going back quickly. Here we have an addition problem. I'm adding integers with 2 different charges. One is a positive, one is a negative. All you do is when we're adding integers, all you do is subtract. 3 minus 2 is 1. You use the charge of the bigger number. 3 is larger than a 2, so I'm just going to make that 1 a positive. That's all that's saying. The charge of the when I'm adding integers, if the charges are different, all we do is subtract. 3 minus 2 gave us the 1. How do I know what the charge is going to be? It's going to be charge of the bigger number. And that's going to be your adding integers.